The first periodic trend is atomic radius. As you go down the periodic table, the radius of an atom increases because you are adding more energy levels, so it gets bigger. As you go across the periodic table, the radius of an atom decreases because there are more protons and electrons causing the atom to contract.
The next trend is ionic radius. As you go down on the periodic table, the ionic radius increases because you are adding energy levels. So, it would make sense that when you're adding more energy levels that the ion would become bigger. As you go across on the periodic table, the ionic radius decreases and resets at the staircase. Before you get to the staircase, the ions become smaller because they are losing more electrons the further you go. For example, sodium and magnesium. Sodium only needs to lose one electron to have a noble gas configuration or a full octet, whereas magnesium needs to lose 2 electrons to have this configuration. So, because sodium is only losing 1 electron, it would make sense that it would be bigger than magnesium, which needs to lose 2 electrons. After you pass the staircase, the ions also get smaller the further you go, because they need less electrons to have a full octet. For example, sulfur and chlorine. Chlorine needs to gain 1 electron to have a noble gas configuration or a full octet, whereas sulfur needs to gain 2 electrons. So, because sulfur has 2 more electrons, it will be bigger than chlorine is.
The third periodic trend is ionization energy. Ionization energy is the energy required to remove an electron. As you go down the periodic table, the ionization energy decreases because there is more distance between the nucleus, where the protons are, and the valence electrons. Since there is less attraction holding the valence electrons to the atom, it is easier to remove an electron. As you go across the periodic table, the ionization energy increases. Since the atom wants to gain more electrons, it is harder to take one away because after you cross the staircase, the atoms want to gain an electron to have a noble gas configuration. So because they want to gain an electron, they would be less likely to give one up and would therefore have a higher ionization energy. Atoms like sodium would have a lower ionization energy because it wants to lose an electron to have a noble gas configuration, so it would be more likely to give one up.
The final periodic trend is electronegativity. Electronegativity is the general attractiveness an atom has for additional electrons, and it is a rating system. As you go down on the periodic table, electronegativity decreases. This is because the further down you get on the periodic table, the more energy levels are being added to that atom. Because the protons are in the nucleus, which is inside the core of the atom, the further they are from additional electrons, so they would not be able to attract the electrons as easily. As you go across on the periodic table, the electronegativity increases. This is because atoms like fluorine want to gain electrons to have a noble gas configuration or a full octet. So they would have a high electronegativity or attractiveness for electrons. Atoms like lithium would have a lower electronegativity because they would like to lose an electron in order to have a noble gas configuration or a full octet. So this would result in them having a lower electronegativity.